Hey guys, today we're going to graph quadratics, okay? And we can also say we're graphing parabolas, all right? So the first thing you need to do is download this little note sheet that I made for you, and it's in Google Classrooms, okay? Let's take a look at this right here. It says y equals x squared, y equals x squared. Well, this is the parent graph, okay? Now we've done something like this before. Remember when we worked on absolute value? We had a parent graph. This is something very similar to that. Okay? So what we want to do here first is I've got to pick some numbers here, and I got to put them into the problem and see what happens here. Okay? So a good number to pick would be 0, right? So if we said to ourselves, okay, let's pick a number like 0. We'll put 0 into this problem. Okay, see what happens. So if I put a 0 in right here, 0 squared is 0. So x is a 0, y is a 0. So when we put a 0 in, we get a 0 out. Okay, that's right here. All right. Probably another good number would be 1. Let's take a 1 and we'll put a 1 in this problem. Now what's 1 squared? 1 squared is 1, right? So when I put a 1 in there, I get a 1 out. Okay, so when I put a 1 in, I get a 1 out. Next thing you want to do is pick another number. By the way, 1, 1, okay, is going to be right there. So when we graph it, it's right there. How about a 2? Let's put a 2 in this problem. So 2 squared. When I square 2, I get 4, right? So when I put a 2 in the problem, I get a 4 out. So when I put a 2 in, I get a 4 out. Right? So if I go 2 to the right and I go 4 up, that's right there. Okay? Now a parabola is a U-shaped figure. Okay, U-shaped, not a V. That was for absolute value. And the good thing about a parabola is whatever you have on the right-hand side, the shape that you have on the right-hand side, it's going to be the same on the left-hand side. There is a line that goes right down the middle. Okay, splits the figure in half. Okay, that's called a line of symmetry. And in this case, on the parent graph, it's going to be right here. It's going to go straight down the y-axis. Okay, so our axis of symmetry is x equals 0. Okay, and you'll get the hang of this in a minute here. I'll show you. All right. So if I look at this, I say, okay, if I went 1 to the right here and 1 up, I can go 1 to the left and 1 up, and that's going to match that point. Okay. Now, if you don't believe me, we can put negative 1 into the problem. Negative 1 squared, okay, is 1, right? So negative, if I put in a negative 1, and a 1 comes out. So that would be negative 1 to the left and 1 up. And what happens when I put in a negative 2? Negative 2 squared, that's a negative times a negative, which would be 4. So that's going to be negative 2 and positive 4, right? So we go negative 2, positive 4, that's going to be right there, okay? And if you look at these points, notice that this one here is 1 to the right of that axis of symmetry. This is 2 to the right of the axis of symmetry. And what this looks like is it comes down like this to that point there, and then it goes up like that. And I put arrowheads on the top because that means it goes on forever. Okay? Now there's a couple questions down here on the bottom. Let's answer those. Domain. Domain are the x's, the x values. What number can I put in for x? Okay. Now here's a 1, and here's a 2, here's a 3. And notice this keeps going up forever, so I can put in any number to the right. So I can put a 1, a 2, a 3, a 4, a 5, forever. It goes on forever. It also goes to the left, so I can put a negative 1, a negative 2, negative 3. So I can put in basically any number, or all reals. Okay? Now the range is basically how high or low this goes. Now if I had a line going across this way, when I got to this point right here, okay, right here at the x-axis, the figure is not below that. So y has to be greater than or equal to 0. Okay? That kind of makes sense? Hopefully it does. Okay. Now let's take a look at number 2. Number 2 is similar to the parent graph except for there's a negative sign in front, right? So it's going to change some of the values. So, like this one, let's start off with a 0. Let's put a 0 in this problem, and I'll do it over here. Okay? This is where I'm going to show it work for. This is number 1, and this is number 2. Okay? Here's my x values, here's my problem, and here's x and y. That's the input, the output. So if I put a 0 in this problem, okay, put a 0 for x, that's 0 squared, but then there's a negative sign out in front. Okay, basically what's going to happen here is you're going to get, you can't have negative 0, so it's going to be 0, 0. So that's right here. Kind of like this one right here. Now if I put a 1 in the problem, let's see. Remember this minus sign is on the outside. So if I put a 1 in this problem, that minus sign on the outside, so 1 squared is 1, but then there's a minus sign after you square it. See, it's after, so that gives me negative 1. So when I put in a positive 1, I get a negative 1 out. Okay? If that doesn't make sense to you, we'll do another one. Okay, let's put a 2 in the problem. So put a 2 in for x right here. You square that, you get 4. But then after that, there's a minus sign. So that gives me negative 4, right? So you put a 2, you get a negative 4 out. Okay? So let's graph these points. We have 0, 0 already. Then we graph 1 to the right, and then it says negative 1, so we have to go down 1. This says 2 to the right and down 4. So that's like right there. Okay? Now, we could try some numbers on the left-hand side here. Okay? For example, we could put a negative 1 in here. Let's see what happens when we put a negative 1 in here. Remember, negative 1 squared, you have to do that first. Negative 1 squared, that's negative 1 times negative 1, which would be positive 1. And there's a minus sign after that, so that gives me negative 1. So that's negative 1, negative 1. So that's 1 to the left, and then 1 down. That's right there. Now, as you can see, you got kind of a curve right here. And you notice that this is 1 to the right, and that's 1 to the left. This is 2 to the right. So the next one's going to be 2 to the left, right? So you notice that is a parabola that's facing downward. It's basically the parent graph flipped over. And I bet you can guess why this flips over. Remember the minus sign out here in front? That makes it flip over or flip over the x-axis. Okay? Here I can fill in this chart here. So when we put a 1 in, we got a negative 1 out, right? When we put a 2 in, we got a negative 4 out. We put a negative 1 in, we got a negative 1 out. And then when we put in a negative 2, we got a negative 4 out, right? Okay. Our domain on this one, what can you put in for x's? You can put in any number to the right or any number to the left, so it's all reals. The range now is different on this one because on the first problem on our parent graph, everything was above the x-axis. On this one, everything is below the y-axis, right? I'm sorry, it's below the x-axis. Everything's below the x-axis. So my range is y has to be less than or equal to 0 because it's underneath. Okay? This figure right here is underneath the x-axis. So all the numbers have to be smaller. They have to be less than 0. See, negative 1, negative 2, negative 3, negative 4, and so on. Axis of symmetry, it's the same as this one. So it's x equals 0. Right? Okay. Now we got a couple vocabulary words that we have to talk about. And some of these vocabulary words are this point right here, this point right here. This happens to be the point where the parabola changes directions. See, it's coming downward and then it starts going up. So this is the lowest point. It's called a vertex. Okay? And when it's at its lowest point, see how it goes down here? This is the lowest it goes. That's called a minimum. On this problem here, my vertex, it's not a minimum. It's as high as it goes, so that's a maximum. Okay? Now, see this figure right here? Okay, to me it kind of looks like a coffee cup. You know, a coffee cup goes like that. Okay? I call this a fill. Okay? And this one over here, the coffee cup is upside down, so what's going to happen to the coffee? It's going to spill. So I call this one a fill. I call this one a spill. Now that's something that I use, but not every teacher uses that. Alrighty? Okay. Why don't we try this one right here? Now notice that this has a -2 in front of it. So it's not the parent graph, right? The parent graph would look something like this. The parent graph would have a point at 0, 0. Well, since this one's negative, and you see the way they drew the graph, it's below, so it's the parent graph reflected over the x-axis. So it would look more like this one here. So it would be right here, right? That would be 1, -1. So there's another point over here, and then remember other point, this one right here. This was 2 to the right and 4 down. So this is 2 to the right and 4 down. This is 2 to the left and 4 down, right? So this one would look like that. That's what the parent graph would look like. The parent graph flipped over the x-axis. Remember, this is the parent graph. This is the parent graph flipped over the x-axis, or reflected over the x-axis. So this was what my parent graph would look like if it was reflected over the x-axis. Now let's kind of see what happens on this problem here, okay? Because now I have a -2 here. So let's do this problem, and we'll do it right here, okay? So let's draw a little table right here. Put my x values there. Y equals -2x squared. This is going to be x and y, right? And probably a pretty good number to pick would be 0, right? So we'll put a 0 in this problem. If I put a 0 in here, it's going to be -2 times 0 squared. Let's see what we come out with, okay? What's 0 squared? That's 0. What's 0 times -2? That's 0. So we have a point right there, just like the parent graph that's reflected over the x-axis. Now let's see what happens when we put like a 1 in this problem. So if I put a 1 in this problem, that's like 1 squared, and then there's a -2 out in front of it. 1 squared is 1. 1 times -2 would be -2. So when I put a 1 in, I get a -2 out, right? And let's try a number like 2, okay? Put a 2 in this problem, you square it, you get 4. And then 4 times -2 will give me -8, right? So when I put a 2 in, I get a -8. So let's plot these points. Usually what I do is I find 3 points to the right or to the left of the vertex, and then I just copy, okay? So this says 1, -2, so 1 to the right, down 2. And this says 2 to the right, down 8. 2 to the right, down 8. That is, it's hard to see these numbers. I think it's right here, okay? Now you see this point right here? It's 1 to the right of the y-axis. So the next point is going to be there. This is 2 to the right. So we go 2 to the left. And when you draw it in, it looks like this, right? And if you remember, when we were talking about absolute value, okay, this is a stretch by a factor of 2, okay? So my domain in this problem is once again all reals. My range in this problem is, remember, all the numbers are below the x-axis, below the x-axis, so y has to be less than or equal to 0. And then once again, my axis of symmetry is x equals 0. Now, it's kind of weird because all these have the same axis of symmetry. When we do some other problems, it might be a little bit different. Okay? So, let's flip this over and see what's on the back. This one I'm going to skip. If you could figure this out, you see this problem, they're basically the same. The only thing that's different is this has a minus sign, that one doesn't. So you see this blue parabola, it's going to be the same thing, but it's going to be above the x-axis. Let's take a look at this one, okay? We'll do number 5. Let's do number 5, okay? And we'll do number 5 right here. Okay? So number 5, get your x's, then y equals -1/2 x squared, then your x and your y, right? So on this one, let's try to put a 0 in first, okay? Some of you guys are probably asking, you know, do we always put in a 0? For now, yes, but eventually, no. In a day or two, we're going to show you how to figure out those numbers, okay? So if I put a 0 in this problem, it's going to be -1/2 times 0 squared. Well, 0 squared is 0. 0 times -1/2 is 0. So 0, 0 is right there. I bet you can guess that's our vertex, right? Put a 1 in there, okay? So 1 squared is 1 times -1/2. 1 times -1/2 would be -1/2. So when I put a 1 in, I get a -1/2 out, right? So I go 1 to the right and down 1/2, which is right there. It's kind of hard to see on the graph, but that's where it's at. Okay? Now, can you guess what would happen if I put a -1 in there? If I put a -1 there, do you know what's going to happen? What's -1 squared? That's -1 times -1, which is 1. 1 times 1/2 would be -1/2. So if I go to the left one and I go down 1/2, I'm right there. And you should kind of see there's a parabola right there. It's starting to make the shape. Let's stick a 2 in here, okay? 2 squared is 4. 4 times -1/2. What's 4 times 1/2? 4 times 1/2 is 2, but it's a negative, so it's a -2. So basically it'd be 2 and -2, right? So if I go 2 to the right and 2 down, that's right there, right? This is my vertex right here. Okay, and how do I know it's my vertex? Well, it's gonna come up and it's gonna start to come down. So if this is 2 to the right, and then down 2, I'm gonna go 2 to the left and down 2. It's gonna be right there. So my parabola looks like that. Okay, and you know, like I said earlier, some of the vocabulary words. This is my vertex. Is this a max or min? Well, since it's the highest point, it's a maximum, right? And then, is this a fill or spill? I would call this a spill, right? That's what I call it. The book doesn't call it that, but that's what I call it, okay? what's my domain? My domain, again, is all reals. My range, since it's below the x-axis, my range is y has to be less than or equal to 0. And then my axis of symmetry, sometimes called a line of symmetry, axis of symmetry, okay, it's x equals 0, okay? The only thing that we have to talk about next, the last thing we're going to talk about is standard form, okay? Standard form. What's standard form? Standard form, and I'll just put it on the bottom here. Standard form. You can put it on the bottom of your notes. Okay. You know how we have y equals mx plus b that makes a line? Well, when we talk about quadratics, okay, we say y equals ax squared plus bx plus c. That's standard form, okay? Now, some of you guys say, okay, well, do you have an example? Yeah, we could say y equals 3x squared, okay, plus 5x plus 2 or something like that. That's in standard form. It's the x squared first, then the x, and then the constant, okay? Sometimes they say f of x equals, and it could be like negative 2x squared plus 3x minus 5 or something like that. That's standard form. And we're going to talk more about that in a day or two. But yeah, that's pretty much the basics. And I'll post some homework for you to do. Basically, you just have to, they give you the numbers that you plug into the problem, and you just have to figure out, okay, if I put in this number, what's the outcome? Then you plot the points, and then you make the graphs, okay? And remember, all these graphs make parabolas. They don't make lines. They don't make any other shape. They're all parabolas. All righty? Hope you had a good day. Talk to you later. Bye-bye.